let's try this graphing word problem. The distance from A to B is 100 kilometers. Andy leaves position A and travels towards position B at 80 kilometers an hour. At exactly the same time, Maya leaves position B and travels towards position A at 40 kilometers per hour. Use algebra to determine exactly how long it will take for Andy and Maya to pass on the highway. So while it's not necessary to sketch a diagram, it might be helpful to do so, just to make sure that we minimize errors. So recall that we have a distance time graph, and Andy here is the red line. He's traveling at 80 kilometers per hour. So 80 kilometers within 1 hour would mean that in 1 hour we're going a distance of 80. So here, this final position is at distance 80. Remember that the slope of a distance time graph is the speed, is the velocity. So in this case, Andy's just driving on by at the same speed here, starting from the beginning point over here. And Maya is leaving position B, which happens to be 100 kilometers away, and travels towards position A. So here, at 40 kilometers an hour, Maya is already at the end goal of 100 kilometers away. So this is where Maya is, and she's traveling back close to where Andy was, which is at position 0. How fast? With a slope of 40 or negative 40. The key here is that if you're traveling back, distance is decreasing, and so the speed here, the slope is 40, but really it makes sense to respect the sign. When we're going downhill, when the distance is decreasing, downhill means we have a negative slope. So 40 kilometers an hour is pretty fast, but we have to respect the fact that slopes also have signs. The velocity, a negative velocity, means we're coming back. So for every 1 hour, we're going down 40 units in terms of distance, 40 kilometers. So 1 hour passes here, 1, 2, 3, 4. 1 hour passes by, 1, 2, 3, 4. We can sketch this and get a rough estimation of the time when Andy and Maya pass each other, which is the point of intersection. Now the question here is, says use algebra to determine exactly how long it will take for Andy and Maya to pass on the highway. So it's nice to estimate using drawing a picture, and it's nice to see exactly what kind of lines we're dealing with. However, using algebra, we know that the equation distance equals velocity time is the key, where d is our y value, and t is our x value, and v is the slope. But what are our two key line equations? Well, we can do Andy's line here in red. We can see this is simply a y, or distance, equals the velocity here is 80, and then the y-intercept would be plus 0, since we're just starting here. So there's so 80t would be the first line equation. The second line equation would be the green line here, which would be distance is equals to, we have a downward speed, would be negative 40. The key is negative, and that's our x value, and the y-intercept would be plus 100. So we have the two key equations, two different unknowns. We can solve for d and t. Now, because the two d's are the same, we can simply equate these other two pieces here. We'll say that 80t is equals to negative 40t plus 100. I'm going to move this negative 40 over, so I have 120t is equals to 100. Divide both sides by 120. We get t equals 100 over 120. So we're talking about hours, so this is approximately equals to, well, it's exactly equals to 0.8333 repeater hours. And then if you want minutes to the nearest minute, if that's what the question was, I'd multiply by 60, since there's 60 minutes in an hour. So if we want minutes, it's the same thing as 50 minutes. So this is exactly actually 50 minutes, 0.8333 hours times 60 is 50 minutes. So this question is quite involved. It requires a strong understanding of graphing, and the key is to understand the distance, velocity, time formula. Distance equals velocity, time. Understand the meaning of velocity, which is the slope. Also appreciate how to sketch graphs, and remember that when we're going back from the end goal towards where you're starting from, we're dealing with a negative slope, and we have to appreciate the y-intercept as well. Once we have the two different line equations, these are two lines, we can find the point of intersection by equating these two equations and solve for t. And of course we can always convert to minutes if we wish to do so. And once we have t, the exact t value, which is going this way to the right, we can always plug it back into any of these equations to also solve for the specific distance, the location, the point of intersection. Amazing job. This question was kind of involved, but if you understand this, you are going to be able to solve some great problem in the future, such as world hunger or something.